Good morning, good afternoon, and good evening to everyone who joins us from around the world. We're so glad you're here.
We really are.
This is Andrew and Renee.
Welcome to the Stack series.
Today we are exploring the erosion of human memory.
It sounds so grand when you put it like that, doesn't it? The erosion of memory.
It does. It sounds like a poem or something.
Exactly, like a Dali painting, all Velton clocks and sand. But, as we were digging through the stacks of research for this, it became really clear to me that this isn't just a poetic idea.
No.
It's a terrifyingly practical one. I mean, what we're really talking about is the fragility of, of everything we think we know as a species.
I have to admit, when we first started on this topic, my mind went straight to the movies. I'm thinking, Indiana Jones, Atlantis.
Of course.
That scene in every single adventure movie where the hero finds some ancient, dusty book that holds the key to, like, a lost super weapon or some forgotten high-tech secret.
Right. The secret is always in a book.
Always. And there's this really romantic idea that the past is this big treasure chest, and it's just sitting there waiting for us to find it. You just have to, blow off the dust, crack the spine.
And boom, the answers to everything.
Exactly. The answers to everything.
And it's a beautiful image. It sells a lot of movie tickets, a lot of books. But the reality that we found in the source material is it's just so much more chaotic. And frankly, it's much more anxiety-inducing.
So we need to introduce a concept here right at the top to frame this whole conversation.
We do. It's a concept that usually lives in the world of physics, but it applies perfectly to history. And that's information entropy.
Okay, let's unpack that right away, because entropy to me means disorder. It means systems falling apart, heat loss. How does that apply to, history books?
Well, think of it like this. We tend to view human knowledge as a mountain that we're building. Every century, we add another layer, we get smarter, we build it higher and higher.
That's the standard view of progress, right? A straight line going up.
It's the Whig history view. Yeah. That everything just gets better and smarter and faster. But information entropy suggests we should think of our knowledge more like a library.
Okay.
But this library is constantly, and I mean constantly, on fire. Just a little bit in the corners. Or the roof is always leaking. Or there are insects just slowly eating the paper.
And we're just running around trying to save the books.
We're frantically running around trying to copy the most important books before they completely disintegrate into dust.
Wow. That is a stressful image.
It is.
It completely changes the role of a historian from, like, a discoverer to more of a first responder, a paramedic for data.
That's a great way to put it, a paramedic for data.
Yeah.
Because history isn't a steady, guaranteed climb. It's this precarious, desperate struggle against loss. We think that once we learn something, how to build a gear, how to cure a disease, how to make concrete, that we keep that knowledge forever.
Right. It's saved. It's in the bank.
But the sources we have today show us, again and again, that's just not true. We forget. We lose the recipe. The instructions turn to dust.
So our mission today is to really get into how that loss happens. And it turns out it's not just about big, dramatic library fires, though, that definitely happens too.
It does.
We're going to look at specific examples of lost technology. I mean, actual machines that vanish from history for 1,000 years.
We're going to look at the human cost of erasure, especially when it comes to indigenous cultures.
And this is where it gets really interesting for me. We're going to ask the question, are we losing knowledge right now? Is our digital age actually a kind of dark age in disguise?
Precisely. So we'll start with the foundations, what we think we know about history.
Then we'll get into the active debates, where science is still arguing over lost tech.
After that, the frontiers, where we're finding incredible new ways to recover lost voices.
And finally, the implications. What does all of this mean for us today in our society?
So let's jump in. The foundations.
Yes, let's. Because when people talk about lost knowledge, there's one place, one event that everyone immediately brings up.
I know exactly what you're going to say.
The Library of Alexandria.
Of course. It's the pop culture shorthand for we lost everything.
It's the ultimate symbol of loss, right? The Titanic of libraries.
Perfectly put.
Right. The story we all learn in school is that there was this one massive library. It contained all the wisdom of the ancient world, Aristotle, Plato, all the lost plays of Sophocles, maybe even, blueprints for steam engines.
Right. The myths get pretty wild.
And then one day, Julius Caesar, or maybe a Christian mob or someone, set it on fire and poof. Humanity was set back 1,000 years. The story goes that if that fire hadn't happened, we'd have been on the moon by the year 1400. That's the vibe.
That's the vibe. It's a very clean, very cinematic narrative. Gives us a villain. It gives us a single tragic moment in
Oh,
time.
it sense a but.
But if you actually dig into the historical analysis, especially from sources that are looking into these great myths of history, the reality is
Well,
it's far more mundane.
mundane how?
And,
Yeah.
in my opinion, it's far more instructive about how the world actually works.
So you're telling me it wasn't just one big dramatic fire?
No,
No.
it wasn't a single event where everyone is standing outside in the street weeping while the scrolls burn in a giant funeral pyre.
Yeah.
The destruction of the Library of Alexandria was more like a slow-motion car crash that lasted for centuries.
Centuries.
Yes. Okay, so yes, Caesar's campaign started a fire near the docks around 48 BC. It might have singed a warehouse that was holding some scrolls for export. That probably happened.
Okay, so there was a fire.
There was a fire. And yes, there were riots later under the Emperor Aurelian. But the real killer, the thing that did the most damage.
What budget cuts?
You're kidding, budget cuts. That sounds uncomfortably modern.
Yeah.
I was expecting barbarians at the gate, not an accountant with a red pen.
It's bureaucracy, it's neglect, it's institutional decay. You have to understand the sheer materiality of ancient knowledge.
What do you mean by that? We forget this because we're looking at screens all day, but information used to have a physical body. It was a real thing. They weren't writing on acid-free archival paper or, storing data in the cloud with 3 different redundant backups.
No, they were using papyrus.
They were using papyrus.
Which is a plant. It's made from reeds that grow in the Nile.
Exactly. It's organic material. And in the humid climate of Alexandria, which is right there on the Mediterranean Sea,
It rots.
it rots. It gets moldy. It gets eaten by silverfish and bookworms and beetles. A scroll has a shelf life, maybe a century, maybe 2 if you're really lucky, and you keep it perfectly dry.
So if you don't have an army of scribes who are constantly copying the old crumbling scrolls onto new ones,
The knowledge just disappears.
Yeah.
It literally turns into dust. It rots away.
so it's an active maintenance issue. It's not like a stone tablet where you just carve it and forget it. If the funding for the library dries up, the copying stops.
And the history literally disintegrates in your hands.
That's incredible.
And then you have the transition to parchment.
Animal skin.
Right. Which happened later.
Right.
Parchment was way more durable. It could last for 1,000 years. But it was also exponentially more expensive.
You have to raise a whole sheep.
You have to raise a sheep. You have to skin it. You have to treat the hide with lime, scrape it. It's a long, laborious process. So difficult choices had to be made.
This is what the sources call the economic triage of history.
That's it. What do we spend the money to copy onto this expensive new parchment? And what do we just let rot? That selection process, that's where we lost huge chunks of Greek drama and science.
Can you give us a sense of the scale of that loss?
Okay, take Sophocles, one of the greatest playwrights in all of human history.
Right.
We have 7 of his plays today. 7. We know from records that he wrote over 120.
120, so we've lost more than 100 of them.
We didn't lose the other 113 because some villain burned them in a fire. We lost them because at some point, some librarian or some scribe made a decision that they weren't popular enough to justify the cost of the sheep.
That's almost scarier, isn't it?
It is.
It's not malice, it's just indifference. It's the apathy of the present, just casually erasing the past. It's applying popularity contest logic to the sum of human wisdom.
Exactly. But moving on from that, the sources do give us plenty of examples of actual intentional malice.
A hard delete of history.
Yes. We can't let humanity completely off the hook. Sometimes we burn the books on purpose.
And for that, we have to look at the Qin dynasty in China around 213 BC. This wasn't neglect. This wasn't budget cuts. This was Emperor Qin Shi Huang deciding that history should start with him.
The year one mentality. It's terrifying. We see this with totalitarian regimes throughout history. But Qin Shi Huang was really the innovator of this specific brand of erasure.
He ordered the burning of books and burying of scholars. It's a phrase that still sends a chill down my spine.
He specifically targeted the Confucian text, right?
Yes. History, poetry, philosophy. Basically anything that could be used to criticize his rule by comparing it to the past rulers, the past dynasties.
That's the key to it. He wanted to sever the link between the people and their ancestors. Because if you don't know that things were ever different before,
You can't imagine them being different in the future.
it freezes the political imagination in place.
But it's so interesting what he didn't burn. The sources are really clear about this. He kept the books on medicine, divination, and agriculture.
Which tells you everything you need to know about his priorities, doesn't it?
It really does.
He kept the technical manuals. How to grow rice, how to heal a broken leg, how to predict the weather for planting. But he destroyed the wisdom, the moral framework, the historical context of the entire society.
He wanted a population that could work and produce, but not one that could think or remember.
It's state-mandated forgetting, pure and simple, all to consolidate power. If you control the past, you control the future.
And it reminds me of another tragedy from the sources, Nalanda University in India.
Oh, this one. This one really hurts to read about.
It really does. I hadn't realized the scale of this place. It wasn't just a library.
No, not at all. Nalanda was a massive residential university. It flourished for centuries. Think of like an Ivy League campus, Harvard or Oxford.
Okay.
But for Buddhist philosophy, astronomy, logic, mathematics, they had dormitories for 10,000 students, kitchens, lecture halls, thousands of scholars living and working together. It was a literal city of learning.
And then around 1200 CE, it was destroyed.
By Turkish raiders, a general named Bakhtiar Khilji. And the accounts of the destruction, I mean, they're just chilling. They say the library was so vast, it was in 3 massive multi-story buildings, that when they set it on fire, it smoldered for months.
Smoke rising for months.
Yeah,
That is the physical manifestation of information entropy right there.
It is.
Just imagine the sheer volume of fuel, of manuscripts required to keep a fire burning for that long. We're talking about millions of texts.
And unlike Alexandria, which was a slow, sad decline because of economics.
This was a decapitation.
That's the word. A decapitation of a culture. This was a specific cultural repository, theology, astronomy, logic, wiped out by conquest.
Yeah.
You burn the place where the teachers live and teach, you kill the masters, you burn the books, and suddenly 1,000 years of mathematical progress is just gone.
This brings us to a huge debate that's mentioned in our sources about the so-called Dark Ages.
Right.
There's this popular internet theory, I see it on Reddit all the time, usually in a meme format, that after the Roman Empire fell, Christianity basically came in and destroyed all the ancient science, banned math, murdered the smart people, and threw Europe into 1,000 years of ignorance.
The Hypatia narrative.
Exactly. The idea that religion is fundamentally the enemy of science. And while there was certainly tension, I mean, we can't deny that.
It's not.
The historical sources we've looked at, especially the ones analyzing these great myths, suggest this is a massive exaggeration.
It is. It's a very simplistic narrative that doesn't hold up.
So the church didn't just go around burning all the science books.
Not exactly. In fact, for huge stretches of the early Middle Ages, the monasteries were the only places that were preserving books.
Right. The monks were the scribes.
If it weren't for monks painstakingly copying texts by hand, we would have lost even more than we did. The Dark Ages were caused far more by the collapse of the Roman economy and its supply chains than by any religious edicts against learning.
Unpack that for us. How does a bad economy destroy science?
Well, think about the materials again. It always comes back to the materials. When the Western Empire fell apart, the money for those scribes we talked about, it just disappeared. But even more importantly, the trade routes that brought papyrus from Egypt to Europe completely collapsed.
So the Mediterranean was no longer a Roman lake.
Exactly. It became a conflict zone. You couldn't get a steady supply of your primary writing material anymore.
So it's a shortage of materials again. You can't do complex geometry if you don't have anything to write on.
Precisely. And institutions like the Academy in Athens, it didn't close because some bishop outlawed geometry. It closed because it ran out of funding or it got caught in political crossfire, like Sulla's Siege of Athens, which happened long before Christianity was the dominant force.
So it goes back to that really unsettling idea that loss is often just mundane.
It is.
It's economics, it's rot, it's the collapse of the postal service. It's buoying, but it's utterly devastating.
And that is a perfect segue into our second section, the active debate.
Right.
Because while a lot of loss is mundane and boring, there are things we've found that suggest we really did lose some spectacular high-tech capabilities. Things that, according to our neat timeline of progress, just shouldn't exist.
Here is where it gets really, really interesting for me. We have to talk about the Antikythera mechanism.
We do.
This is my favorite historical artifact, hands down. It feels like finding a crashed UFO. It feels like time travel.
The mechanism is the smoking gun of lost technology.
Yeah.
Completely upends the entire timeline of engineering.
Okay, for anyone who hasn't seen pictures of this thing, paint the scene. It was found in a shipwreck in 1901, right?
That's right. Off the coast of a small Greek island called Antikythera. Sponge divers found an ancient Roman wreck. It was full of marble statues, jewelry, luxury goods.
And buried in all this beautiful stuff, they found this lump.
A lump of corroded bronze, dated to roughly 150 to 100 BCE. At first, it just looked like a green rock. They almost threw it away.
But they didn't.
They didn't. And when they eventually got it back to a museum and x-rayed it, they found gears.
Precision gears?
Tiny, intricate precision gears.
And not just a couple of wheels turning. We're talking about more than 30 interlocked bronze gears.
It was an analog computer, a mechanical astronomical calculator.
What could it do?
It was used to predict astronomical positions, solar and lunar eclipses, and even the 4-year cycle of the Olympic Games. It could track the sun, the moon, and the 5 planets visible to the naked eye.
But the craziest part is how it tracked the moon, right? The moon's orbit isn't a perfect circle?
Exactly. That's the genius of it. The moon's orbit is elliptical, which means it speeds up and slows down depending on where it is.
And the machine accounts for that.
It does. It had a specific ingenious gear setup, a pin and slot mechanism that mimicked that variable speed. That is a level of sophisticated mathematical modeling that we just didn't think existed back then.
The thing that just blows my mind is the context. We don't see anything with that level of gear complexity again for over 1,000 years.
Not until the great astronomical clocks in the cathedrals of 14th century Europe. That's a millennium-long gap. 1,000 years where humanity apparently forgot how to make complex gears.
And that's the active debate, isn't it? Why is this the only one we've ever found?
That's the question. If you have a machine this complex, it implies a tradition. You don't just wake up one Tuesday and invent the Antikythera mechanism from scratch.
No, there must have been prototypes, masters, apprentices.
Whole industry of high-tech gear work. A whole school of thought.
And it all just vanished. No manuals found, no workshops, no other examples, just this one solitary device at the bottom of the sea.
It completely challenges that linear view of progress we talked about. We assume we always get smarter, we always build on what came before, but here is solid physical evidence of a peak of technology that was reached and then completely, utterly forgotten.
It suggests that even high technology can be incredibly fragile. If the workshop burns down or the master craftsman dies without passing on his skills,
the art dies with him.
And speaking of lost arts, we have to talk about Roman concrete. Because if the Antikythera mechanism is all about delicate, complex precision, this is about brute strength and impossible longevity.
Oh, this is one of my favorite examples because it's so tangible. You can go to Italy today and see these structures. Harbors, breakwaters, aqueducts.
And they're 2,000 years old.
2,000 years old and still standing. They are literally being battered by the ocean every single day for 2 millennia, and they are fine. Meanwhile, our modern steel-reinforced concrete starts to crack and crumble after 50 years in the same environment.
And for the longest time, we just didn't know how they did it. It was a genuine mystery. We had the buildings, but we didn't have the blueprint.
Scientists debated this for decades. Was it the volcanic ash they used, the pozzolana? Was it something about the seawater?
And the sources point to a fascinating conclusion that links right back to what we were saying about the fall of Rome.
It does. It turns out the Romans used a very specific mix of volcanic ash and lime. And when that mixture reacts with seawater, it forms a rare, incredibly stable mineral called aluminum tobermarite.
So the seawater doesn't destroy it.
Yeah.
It actually makes it stronger.
Yes. It's self-healing. As tiny cracks form and water seeps in, it triggers new chemical reactions that create new crystals, binding the concrete even tighter. Modern concrete is designed to be inert and repel water. Roman concrete was designed to live with its environment.
Okay, so if it was so amazing, why did we stop making it? Did we just forget the recipe?
And this leads us to what the researchers call the supply chain argument. It wasn't magic. It wasn't a lost secret spell. It was logistics.
Logistics.
The Romans had a massive, functioning empire that could ship this very specific type of volcanic ash from the Bay of Naples to wherever they were building a harbor, to Israel, to Britain, to North Africa. When the empire fell,
Those ships stopped sailing.
the supply chain collapsed.
I love the analogy that's used in the research here. It's like making brownies.
It really clarifies it, doesn't it?
It does.
Imagine you have a perfect recipe for brownies, and it calls for eggs. It's the best brownie recipe in the world. But suddenly, the supply chain for eggs collapses. Maybe a bird flu wipes out all the chickens. You can't get eggs anymore.
You still have the recipe card. You know you need eggs.
But you can't make the product. The recipe is useless without the ingredients.
So you try to substitute something else. You try applesauce, you try oil.
And it's not the same. It's not a brownie. Eventually, people stop trying. They switch to making cookies instead. And 2 generations later, Nobody even remembers how to make brownies properly. The explicit knowledge, the written recipe might have survived, but the capability died because the system supporting it collapsed.
So the knowledge wasn't deleted like a computer file. It just became impossible to practice until it faded away from memory.
And that leads to a really crucial distinction in how we lose knowledge.
Yeah.
It's the difference between explicit knowledge and tacit knowledge.
Okay, this is a concept everyone needs to understand because it explains so much about our world.
It really does.
Define those for us.
Explicit knowledge is the recipe card. It's what is written down in a book or a manual. Add 2 eggs, bake at 350 degrees. It's data. It's information that can be transferred on paper.
And tacit knowledge.
Tacit knowledge is the skill in your hands. It's knowing exactly what the dough should feel like when it's been kneaded enough. It's the smell from the oven that tells you the brownies are done, not the timer.
You can't write down muscle memory. You can't write down intuition or feel.
Exactly. And that is where the real danger of loss lies. We think because we have libraries, or now the internet, that we've saved everything because we've saved the words. But we haven't saved the tacit knowledge.
The sources mention a concept called coarse epistemes.
Right, the idea that writing is a low-resolution capture of reality. It's a fuzzy snapshot. It captures the what, but it very rarely captures the how.
And there's a classic example of this with Damascus steel or root steel, right?
Yes, a perfect example. We have the swords, we can analyze them. We know they're incredibly sharp, incredibly flexible, and they have this beautiful watery pattern on the blade.
But for centuries, we couldn't reproduce them.
Not properly. We didn't know the exact heating and cooling process they used. It was likely a trade secret, passed down from master to apprentice. It was a feel that the smith had.
Like, heat it until it glows the color of the setting sun.
Exactly that kind of thing. Not heat it to 875 degrees Celsius. So when the master smiths died out, or the specific iron ore they were using from India ran out, the explicit recipe didn't matter. The tacit skill was gone forever.
This connects to a terrifying modern example I want to say for later about nuclear weapons.
Oh, yes.
But let's hold that thought. I want to move on to the frontiers section, because so far this has been a little bit depressing.
Just a bit.
We've been talking about burning libraries and forgotten gears and crumbling concrete. But there is good news. We are getting better at recovering lost things.
We are, and modern technology is helping us to decipher the undecipherable.
Let's talk about Linear B. This was the script of Mycenaean Greece, the civilization from the Trojan War. For years, nobody had any idea what it said. It was just these strange scratches on clay tablets found in the ruins of Knossos in Crete.
A complete mystery. Until Alice Kober and Michael Ventris, this is a classic story of sheer intellectual persistence.
Tell us about it.
Kober, an American classicist, spent her entire life meticulously organizing the symbols on paper grids, finding patterns, figuring out which symbols were vowels and which were consonants, all without knowing what sounds they made.
And Ventris, who was an architect, not even a professional linguist, built on her work.
Right. And he had this brilliant insight. What if it wasn't some lost, mysterious language? What if it was just a very, very early form of Greek?
And he was right.
He was. They cracked the code.
And when they finally did, there must have been this moment of huge anticipation. I imagine the academic world just holding its breath. What did these ancient tablets say? Was it epic poetry? Was it history? The secrets of the gods?
What was it?
It was administrative lists.
Yeah, kidding me.
Seriously. It was accounting, counting sheep, jars of oil, taxes due. My favorite one is 3 tripods with burnt legs.
That is painfully, beautifully mundane.
But it's profound, isn't it? It reveals that writing in many cultures starts as accounting, not as literature. We invent writing to keep track of our stuff.
But the broader point is that with enough data and enough persistence, we can recover these lost voices. And the same thing is happening right now with another script, Linear Elamite from ancient Iran. We're using computer algorithms to find patterns that the human eye might miss.
But writing isn't the only way to store data, and this is a huge, important frontier in the research. Indigenous knowledge system.
This is such a critical correction to our Western bias.
It is. We tend to think if it isn't written down in a book, it's just a myth or a fairy tale.
Oh.
If it's not in a library, it's not science.
But the sources on Australian Aboriginal astronomy just completely overturned that idea.
You call them stories from the sky.
It's beautiful.
It is. Aboriginal oral traditions have been passed down unbroken for tens of thousands of years. And these stories, they aren't just so stories about why the emu is in the sky. They are data. They are science.
What kind of data are we talking about?
They record star maps for navigation. They record the positions of the sun and moon for calendars, and get this, they record the variability of red giant stars like Betelgeuse.
Wait a minute. They noticed, without telescopes, that a single star was getting brighter and dimmer over time.
Yes. Western science only confirmed the variability of Betelgeuse in the 1830s. The Aboriginal traditions have been accurately tracking it for thousands of years.
How? How is that possible? How do you keep that data intact for that long without writing it down? The game of telephone usually ruins a message after 5 minutes.
You encode it. You wrap the data in a memorable narrative. They have stories about a great fire magic figure in the sky, a male hunter whose flame grows and shrinks with his passion.
So the data is hidden inside the story.
And the story is tied to song and to dance and to specific locations in the landscape. This creates multiple layers of redundancy. It ensures the data survives. If you just write down Betelgeuse varies in brightness on a piece of papyrus, the papyrus might rot.
But if you weave it into a song that every child learns, and that song is required for a specific ceremony that's performed at a specific sacred site,
it can survive for 40,000 years.
that is incredible resilience. It's a human library.
Yeah.
The entire culture becomes the storage device.
It is, but it's also incredibly fragile in its own way, because if you break the people...
You break the library.
And that brings us to the Semenys study. This was a piece of research from the Bolivian Amazon that really struck me. It's not about ancient history, it's about what is happening right this second.
This is real-time observation of knowledge extinction.
Exactly. Researchers tracked the Semenys people, a foraging and farming group, over 9 years, between 2000 and 2009. They would test them on their knowledge of wild plants. Which plant cures a stomachache? Which vine gives you clean drinking water? Which wood is best for making a canoe?
And in just those 9 years, what happened?
The results were just stark. Knowledge of local plant uses dropped by roughly 20% in men and 9% in women.
20%. In less than a decade. That is blinding speed. That's the span of a single childhood. What's driving that kind of loss?
Market integration. As the Semenys move closer to towns, as roads are built into the forest, the value system changes. Suddenly, knowing Spanish or math or how to drive a truck is seen as more valuable for economic survival than knowing which root cures a fever.
So the modern knowledge actively displaces the traditional knowledge. It's almost like a zero-sum game. The brain only has so much bandwidth, and society dictates what information is worth remembering.
Exactly. And once that traditional knowledge is gone, it is gone forever. You can't Google, which plant did my great-grandfather use for a snake bite if it was never written down? We are literally observing the erosion of a library that has been built up over thousands of years of trial and error in the Amazon.
You might be losing the cure for cancer because a road was built.
We might be. And this leads us directly into the implications. Because the loss of indigenous knowledge isn't always just an unfortunate economic side effect. Sometimes, as we saw with the Qin dynasty, it is brutally intentional.
We have to talk about cultural genocide and the rhetorics of erasure.
And the sources discuss the Native American boarding schools in the U.S. and Canada. This is a very dark chapter, but we have to face it to understand how memory works, or, more importantly, how it's deliberately broken.
The policy was explicitly stated, wasn't it? Kill the Indians, save the man.
That phrase, from Richard Henry Pratt, is the very definition of intentional erasure. And the method was systematic. You forcibly remove children from their homes and their families.
You forbid them from speaking their native language. You punish them for it.
You cut their hair. You change their names. You dismantle their entire identity piece by piece.
It breaks that transmission line we were just talking about with the Aboriginal astronomers. If the children can't learn the stories from their elders, the library burns. Language isn't just a collection of words. It's the software that a culture runs on.
It contains the entire worldview.
And if you kill the language, you lose the unique perspective that that culture had on the world forever.
And the consequence is what the researchers call historical trauma. It's not just that a group of people forgot some old words. It's a deep psychosocial wound. When your identity is forcibly dismantled, it creates a legacy of pain and loss that lasts for generations.
And it creates that survivorship bias in our history books that we mentioned. We only see the history of the victors or the people who were lucky enough to build in stone.
We miss the history of the people who built in wood, or the people whose libraries were deliberately burned, or the people whose children were taken away from them. It forces us to ask, what are we missing right now? What voices are being silenced today?
And speaking of right now, we need to address the elephant in the room. We live in the information age. We have the internet. We assume we're safe from this kind of large-scale loss.
Right. Once it's on the internet, it's there forever. That's the cliche we all hear.
But the sources suggest we might be, paradoxically, living in a digital dark age.
This is the great paradox of our time. We generate more data in a single day than our ancestors did in a century. But that data is unbelievably fragile.
You brought up the idea of bit rot.
Yes. Just think about this. We can take a piece of parchment from 2,000 years ago, and if you know Latin, you can read it. It requires no electricity, no special hardware, no software updates.
But can you read a floppy disk from 1995?
I don't even have a drive for it. My computer doesn't have one.
Yeah.
Even if the disk itself is perfectly fine, the hardware to read it is in a museum.
Exactly. File formats change, hardware becomes obsolete, the very materiality of digital information is fleeting. We rely on these massive server farms that require constant electricity and cooling. If the power grid goes down for an extended period, the library vanishes.
But it goes even deeper than just old file formats, doesn't it? It goes right back to that idea of tacit knowledge.
It does. The Reddit threads in our sources on this were fascinating. All these IT workers talking about legacy code.
It's the modern version of the Roman concrete problem. You have these massive systems for banking, for airline reservations, for power grids that are running on code that was written 20, 30, even 40 years ago.
And it was written by a guy named Dave, who retired 10 years ago and moved to Florida.
And Dave, God bless him, did not comment his code. He didn't leave a good recipe card.
So no one knows how it works anymore. They're just terrified to touch it. They literally say things like, don't delete that line of code. We don't know what it does, but if you delete it, the whole system will crash.
That is lost knowledge. Happening right now in our super high-tech society, we are actively using machines that we no longer understand.
And there's a specific and, frankly, terrifying example of this from the sources that involves nuclear weapons. The Fog Bank story.
Oh, this one is just wild. Tell us about Fog Bank.
Okay, so Fog Bank is the code name for a classified material used in U.S. nuclear warheads.
Oh.
It's a sort of aerogel, very high-tech, very difficult to make, and it was developed decades ago during the Cold War.
Great.
In the 2000s, the government decided to refurbish some old warheads to extend their life, and they needed to make a new batch of Fog Bank.
It's simple enough, right? Just look up the recipe. They're the military. They write everything down.
They had the recipe. They had the manuals. They had the explicit knowledge. But when they tried to make it, it didn't work. The product was useless. It wouldn't foam correctly or it wasn't stable. They were following the instructions to the absolute letter.
So what was missing?
The people. The tacit knowledge. Because the engineers and technicians who made the original batch had all retired or died. And the feel for the process, the specific way you stir the pot, or the sounds the machine makes when it's working right, or maybe the specific impurities in the raw materials they were using back in the 1970s, none of that was written down.
The impurities, that's the key. They were using cleaner, more modern materials, and the process failed because the original process, without anyone realizing it, relied on the dirtier materials.
That's exactly it. They had to spend millions of dollars and years of research to basically reinvent a material they already knew how to make.
That is Roman concrete all over again, but with thermonuclear weapons.
It is. It shows the incredible fragility of complexity. The more complex our society becomes, the more specialized our skills get, the easier it is to lose entire capabilities if just one or two links in the chain break. If the one person who knows how to make the specific lens for the lithography machine for the microchip dies, we have a serious problem.
So what does this all mean for us? What's the takeaway?
I think it means we shouldn't be arrogant. We aren't immune to entropy. We aren't above the laws of history.
And maybe we need to value maintenance just as much as we value innovation. We need to value the transmission of knowledge, not just the storage of data.
We need to teach the apprentices, not just write the manuals.
Here's a final provocation for you, for everyone listening to think about. If the internet went down tomorrow, or if our global supply chains collapsed, no more ships from China, no more servers in Virginia, what modern knowledge would be lost in just 100 years?
Would we forget how to make antibiotics? Would we forget how to manufacture solar panels? I mean, those things require incredibly complex global supply chains and immense tacit knowledge.
Would future archaeologists dig up a smartphone from a landfill, look at that sleek black glass screen, and wonder, just like we look at the Antikythera mechanism, how on earth did they make this and why did they worship it?
They might just wonder, what were they all looking at? And the answer, all that data will be completely gone.
That is a very humbling thought.
It is. It reminds us that memory is an active process. It's not a file you save once. It's a fire you have to keep feeding every single day.
Well, on that note, we want to thank you for exploring the fragility of memory with us today.
It's been a fascinating, if slightly worrying, journey through the stacks.
Before we wrap up, thank you to all our partners, sponsors, and scholars who made this podcast and the research possible. We're truly grateful for your support.
And to our listeners, thank you for being part of this journey with us. If you enjoyed today's episode, be sure to subscribe and follow Stack Studios for more informative content, and support us in Patreon.
Until next time, stay curious, keep learning, and let the search for wisdom guide you forward. Have a great day.